So in this video, we're going to calculate the extent to which a compound will dissolve first in just water, and then second when there's a common ion present. So first of all, we'll just think about plain old water. So we're going to find the solubility of aluminum hydroxide. And we would need to be given the Ksp for aluminum hydroxide, and that's going to be 2 times 10 to the minus 31. It only has one sig fig, but let's pretend it has 2 just for the heck of it. So first thing I do is I write the reaction. Okay, so aluminum hydroxide is going to ionize slightly to aluminum ion and 3 hydroxides. Okay, so now the aluminum hydroxide is breaking into pieces. So does it make sense that for every one of these, I have 3 of those? Okay, every time I make an aluminum, I make 3 hydroxides. Okay, that's going to help me solve this problem. So Ksp, I write my expression. Concentration of aluminum ion times the concentration of hydroxide ion cubed. So I know Ksp is 2 times 10 to the minus 31. And I'm going to call aluminum X. And then hydroxide ion concentration is 3x. And then the equation says I cube that. So if you do that out, that's going to be 27x to the 4th. So 2 times 10 to the minus 31 is 27x to the 4th. So I go ahead and I solve for x. And that's going to be 9.3 times 10 to the minus 9 moles per liter. This problem is asking us to do it in grams per liter, so all we have to do is change moles to grams. And if you figure out the molar mass of aluminum hydroxide, it is 78.01. So if you multiply that all out, you get 7.2 times 10 to the minus 7 grams per liter. So what that tells us that I can dissolve this teeny tiny bit, 7.2 times 10 to the minus 7 grams of aluminum hydroxide in an entire liter of water. So when we say aluminum hydroxide is insoluble, we're saying it's slightly soluble, but really just very slightly soluble. Now, if I try to figure out the solubility of aluminum hydroxide in a solution that already has hydroxide in it. Okay, so if we look at our equation again, aluminum hydroxide, remember that's a solid, breaks into aluminum ion and 3 hydroxides. So remember Le Chatelier's principle, which says if I add some product, it's going to shift this reaction to the left. So we're going to expect that the solubility of aluminum hydroxide is less than it was just in plain pure water. So I'm going to look at this, and I still have x of this and 3x of this, but from this source I have more hydroxide, SrOH2, so it's going to add 0.05 molar hydroxide. So I'm going to say I have x of aluminum ion, and I have 3x plus 0.05. And then I go ahead and I write my Ksp expression, which is aluminum ion times hydroxide ion cubed. The Ksp for aluminum is still 2 times 10 to the minus 31. So we're going to set that equal to x times 3x plus 0.05 cubed. So that could be a bit of a nightmare to solve mathematically, except we know that x is tiny, right? So we're going to go ahead and assume that 3x is much smaller than 0.05. You can always make this assumption. There's no 5% rule or anything like that. So this simplifies to 2 times 10 to the minus 31 is x times 0.05 cubed. And if you solve for x, you're going to go ahead and get 1.6 times 10 to the minus 27 moles per liter. And you may be able to leave it like that. I asked you to go ahead and change it to grams per liter, so we'll do that. Okay, grams per liter, that's moles. So that's going to come out to be 1.2 times 10 to the minus 25 grams per liter. Now, if you remember from the last slide, the solubility in pure water was 7 times 10 to the minus 7. And this is 1 times 10 to the minus 25th. So the presence of this common ion made aluminum hydroxide a lot less soluble. So let's try one more. Let's calculate the solubility of aluminum hydroxide when we have another common ion present, some aluminum. Okay, so as usual, always write your equation. Okay, the idea is that it helps eliminate mistakes. Okay, and the equation is always the solid breaking into its ions. So it's easier to decide what the equation is with this stuff. You don't have, there's not a lot of that, oh my gosh, I don't know what to write. Again, I have x of this, but I have x plus 0.17, and here I still have 3x. So Ksp is the concentration of aluminum ion times concentration of OH minus cubed. Okay, so the Ksp is a constant, so it's still 2 times 10 to the minus 31. And that's going to be equal to x plus 0.17 times 3x cubed. We're still going to go ahead and assume, all right, that x is much, much smaller than 0.17. So now I've got 2 times 10 to the minus, this is a 31, sorry, minus 31 equals 0.17 times 27 x cubed. And if you go ahead and you solve for your x, you're going to go ahead and get 3.5 times 10 to the minus 11. Again, that's moles per liter, and a lot of times we'll just leave it like that. But since we are doing it, no harm in trying. Grams per mole. And this is 2.7 times 10 to the minus 9 grams per liter. Again, that is less than the solubility, which was 7 times 10 to the minus 7 in pure water. So we learned how to find the solubility in pure water and also with the presence of a common ion.